Basically, all you're doing in percent composition is you're taking the individual weights of every element and dividing by the total, and then multiplying by 100. So we'll just do one real quick here as an example to take a look at. So our example, we're going to look at percent composition. By mass. Is the following formula: C4H6O2. So what we'll do is we'll just find the molar mass of it real quick. So we have 4 carbons, we have 6 hydrogens, and we have 2 oxygens. Multiplied by 12.01. Its total weight it contributes to the overall weight is 48.04. Hydrogen, 1.01. And it's going to be contribute 6.06 grams. And then oxygen is 16. And it's going to contribute 32 grams to the overall weight. Okay? That's a total weight of 86.10 grams. So that's the molar mass. Then all we need to do is take that and divide it into each weight, times it by 100. We have our percent composition by weight. So, remember this?
Yeah.
Okay? All right. So we would go ahead and take the 48.04. And that would be grams of carbon. And we would divide by the 86.10 grams times 100. Okay. And then that would give us an answer of 55.8%.
Times 100, you said?
Yeah. So we just want the percentage. We just multiply it to get the percent. Next one. We just go down the line, 6.06 grams of hydrogen divided by the 86.10 grams total times 100, and we get to 7%. So by weight, a lot of times hydrogen, even though it looks like you got a lot of them, by weight it doesn't contribute very much. And then oxygen would be the next, and then if we wanted to, we could stop there, add those two together, and subtract 100.
Mm-hmm.
And then we could get our remaining percentage. Okay? If we wanted to do that, we could. Or we could just take 32 divided by 86. Okay, and then it should add up to 100, but we always have rounding that happens. It could be 99.9%, it could be 100.1%, depending upon how far you're going to be taking it out. Okay, any thoughts or questions on that? So that's all you're doing. So now, the opposite of this is if I would take these percents, and then I would go back and find the formula. So if I can go through the steps to find the percents based upon the number that I have, then what I can do is take the percentages and go backwards, right? And I can come up with what's called the empirical formula. Okay? So what I would do, now we're not going to do this one, but what I would do is take the percents and just write a gram in for each one of those. So based upon a 100-gram sample, we could say 55.8% of 100 grams is 55.8 grams. 7 grams and 37.2 grams based upon a 100-gram sample. So that's what we'll do. We'll change the percentage to grams, and guess what we do next? We change grams to moles. Okay? And we do that by dividing by their weights. 12, 1, 16. Once we get moles, like you did on your assignment, then we got these odd number moles that are not whole numbers. They're not going to come close to whole numbers because it's based upon 100. The only way it would be moles that'd be right is I think if the molar mass is 100 grams. Then the moles will come out really, really close. Okay, that would be the only way where your molar mass is exactly right around 100 grams, and then it would come out that way. So, let's just do one example like that. I'm going to give you percentages, and I'm going to list the steps out for you, and then you guys can do them. You can predict what the formula is based upon the steps I give you, and then we'll do one that maybe doesn't work out perfect the first time, and we might have to do some little, manipulate the numbers a little bit, okay? So the next one that we take a look at is empirical formula, and I'm going to give you percentages. Now, if I give you grams, and they don't add up to 100 grams or 100%, that's based upon a lab. So like you guys are going to do a lab, and you're going to go through and measure out some weights, and then you're going to get some individual weights that you can just convert to moles. So you can either do percentages, or you can do actual weights based upon data of an experiment or something like that. Okay? So the one we're going to do has the following percentages. Okay? The following percentages are 34.6% gallium, 17.8% carbon, and 47.6% oxygen. So I'm going to list the steps out for you, and you guys just do it. Now you just assume this is based. I'm not going to list this step out, but assume these percentages can be converted to grams based upon a 100 gram sample. So you're just going to substitute in grams for the percent sign. Okay, and then after you do that, you're going to change grams to moles for each one. So moles of atoms. Okay? 2, so we can get these to work out to be whole numbers. We're going to have a bunch of them that will be decimal numbers. So what you would do is you would take and divide by the smallest number of moles of your mole calculations. So you would divide each moles of atoms by the smallest number of moles of atoms.
Divide each one.
There'll be a step 3 on the next one we'll do. So all you have to do is do those 2 steps. And once you do those two steps, then your mole count will be your subscripts. And then you just put them in. I'm not going to put that step down. Okay, that's pretty evident. You come up with a whole number of moles. Those now are your subscripts, and then you write out your equation. Okay? So why don't you do that one, and then we'll see what you get for answers. So these are our moles. And of course 0.496 is smallest. So we just divide all 3 of those by 496. And what this step does,
Okay, Lindsay.
it gets them all into whole numbers. So we go 1, 3, 6. Is that right?
Yeah.
Okay. Now, when you write this formula, sometimes you can be given a little bit of information. I picked this one out for a purpose of showing
That's what I got too.
okay. Now, when you look at your polyatomic ion sheet and you look for C3O6, it's not on there. At least the ones that we have, that we're given. So we can talk a little bit about empirical formulas and molecular formulas. Even though this isn't a molecule, its actual ratio is a little different than this. Does anybody want to guess what it is? What do you think?
Is it GA and then CO32? Like CO3 in parentheses and then 2. No?
That's only
There would be
two C's.
No, it'd be C.
Okay, so
CO2,
that wouldn't be it. So is there another possibility?
CO2, 3. CO2 and then
Oh,
I just
yeah,
switched the
CO2.
3 and the 2.
Do you have a CO2 polyatomic ion?
No.
We have an O2.
Hmm?
I know we have an O2.
Yeah, well that won't work.
We have a CO.
Do you have any CO combinations that we could kind of manipulate maybe?
C2O4.
Okay, C2O4.
I don't know what J.
Could we do GAC2O4 with can we do it this way? What is the charge of GA? Do you have a chart? 3? So if that's GA is a +3 and C2O4 is a -2, so we could say GA2 and this would be a 3. Would that give us a little ratio but then higher numbers?
Yeah.
So 1, 3, 6 is the same as 2, 6, 12. Right? So what you get when you do a percentage, or weights, you get what's called an empirical formula. The empirical formula is the simplest ratio, 1 to 3 to 6, but it may not be the actual formula. Because the actual formula is GA2 C2O4 with a 3 subscript. Okay? Any questions with that? So, how do you know? Well, I picked that one because I thought that would be a good one to see how that can work just by multiplying everything by 2. And when you do that, then you kind of get an idea what the polyatomic ion would be. Now, I will give you this assignment to do. There's some things that if you get to this step here, okay, I'm just going to show it with this as an example, okay? So we're going to make up numbers. I'm making up numbers, and this is maybe how they'll come out to be. Okay, now watch. So if I make up numbers, I say this comes out to be 1.5, this is 3.0, and this is 6.0. We can't round that to 2. What we have to do, and it's kind of like math, where what you can do is you can divide by everything by the decimal that you have. So what if we divide everything by 0.5, what do we get? So 1.5 divided by 0.5, you get what? So we divide everything by that 0.5, we get what? 3, 6, 12. So it's like math where you've got to try to get everything. If this is 1.33, then you would divide everything by
Point.
0.33.
Yep.
Or you can multiply it by 3. I mean, it does the same thing. So you and then everything comes out to whole numbers because your empirical formula doesn't have any single 1 mole of atoms.
You
They're
have to
multiple.
divide, you couldn't like times it by
You could divide, if you recognize that's 0.5, you can recognize I gotta multiply by 2, then
This
you
is
do that. Either way it would work.
What's the shot?
Your announcements for today, I'm going to try
before you
to
go, let me
read them
give you the
loudly so as you're passing you can still hear them. Lunch today, spicy chicken patty on a bun, hot vegetables or spicy
Write
potato
this down. This
wedges,
is due on
roasted
Thursday.
butter squash, or peas and carrots. Reminder, tomorrow is picture day. Remember to bring your picture packet if you're purchasing. Remember your picture packet. Practice that. If you're not purchasing, you still need to report and have your picture taken. Please dress nicely, especially you seniors, because this is the picture that will be attached to your transcript for the rest of your life.
Rest of your
Events and
life.
activities. Golf at the Lincoln Pius is all day today. Tennis plays
Oh, I'm
at York for a duel. Please dismiss the tennis players at 1:30 to depart by 1:45. Softball is hosting Lincoln East at Hannibal. JV play at 5. Varsity at 6:30. Meetings tomorrow. Mentor Science Club is meeting during
See ya.
Mentor. Class officers are meeting during Mentor. Homestead yearbooks are ready to be picked up. Please get that done. We have homecoming.